Today's mini-lecture looks at the geologic timescale and how it was determined. The geologic timescale breaks the vast geologic time of 4.5 billion years into unequal intervals based on changes in the fossil record. So why fossils rather than tectonic changes to define the boundaries in the geologic timescale? Well, because that was the most obvious thing to early geologists. They could see that rocks containing trilobites were always lower down than rocks containing amphibians, for example. Let's start near the bottom at the pink. This is the Cambrian layer. The Cambrian is a period that's characterized by the sudden appearance in the rock record of a great variety of fossils, things that looked like clams and bugs and snails, and a little higher up, primitive fishes. Originally, geologists thought that life began at the Cambrian, but later they found an abundance of soft-bodied fossils in the Precambrian period. The geologic periods, Cambrian, Ordovician, Silurian, Devonian, etc., are defined by observations of a major change in the fossil assemblage. Something new came in, something else went extinct. Most of the Paleozoic divisions were named for the location of the type section, mostly in Great Britain, Cambria in Wales, Devonshire in England, for example. Do you see a break in the pattern? Look at the Carboniferous. It was named for the abundance of coal and other carbon-rich fossils in the rocks, and later it was divided into subunits based on the characteristic sites in Pennsylvania and Mississippi. Actual time on the left in millions of years ago was not determined until much later than these divisions were determined. The biggest divisions are eons and then eras. Let's talk about geologic eras for just a minute. There are 4 that we'll look at in detail. The Precambrian, which is part of the Proterozoic eon, the Paleozoic, the Mesozoic, and the Cenozoic. Let's hear those words again. Proterozoic, Paleozoic, Mesozoic, Cenozoic. They all end in zoic, and you know what zoology is, right? Study of life. So they're all about life. Proterozoic means before life, Paleozoic, early life, middle life, Mesozoic, and Cenozoic means young life. Now, of course, today we know that there was abundant life in the Proterozoic, the pre-life era, and we'll talk about that in a bit. The Proterozoic era began about 2.5 billion years ago and continued until 545 million years ago, the beginning of the Cambrian. So it covers about 2 billion years of Earth history. That's almost half. At the beginning of this time, simple-celled organisms existed. The Proterozoic saw the evolution of multicelled organisms and the first eukaryote cells. Those are cells with complex structures and membranes. Earth had continents and seas, but you wouldn't have recognized the shape of the land masses. About 1.1 billion years ago, the first supercontinent, Rodinia, was formed. The most common fossils in the Proterozoic era are Stromatolites. These are masses of algae which trap sediment and end up looking like fine mounds. They exist in the geologic record starting about 2.7 billion years ago, and they exist in some lagoons today. A fossil assemblage is a coexistence of different fossils that are together in the same rock. In this rock you can see things that look like starfish, you can see things that look like clams, things that look like oysters. An assemblage of fossils can be a very useful thing to tell you something about the geologic time because they can be characteristic of a certain age or a certain environment. They can be used quite well to define geologic periods, and quite commonly that is how we define geologic periods, or by the group of fossils, not just one, but the ones that live together or coexist during that time. One more thing to talk about before we delve further into the geologic eras, and that is mass extinction. Now, species extinction is a normal thing, and it happens at a background level all the time of something like 5 to 7 families per million years go extinct. There have been 5 mass extinctions, however, in the geologic past. And this is a time when at least 50% of all species go extinct in a very short period of time. So mass extinction creates an opportunity for evolution. After a mass extinction, there's an ecological niche to be filled, and so species evolve relatively quickly. There have been 5 major mass extinctions in geologic history, and we're going to look at them in more detail later. But what you need to know now as we define geologic eras is that they very commonly end in a mass extinction. And that's because, remember how we defined them? We defined them by the fossils that lived there. So when the fossils change rather abruptly, as they would with a mass extinction, we define a new geologic era. So the Paleozoic era, that lasted from about 545 to 248 million years ago. At the beginning, we saw the very first hard-shelled fossils. That was the start of the Cambrian. There were 3 mass extinction events during the Paleozoic, at the end of the Ordovician, the Devonian, and the Permian. And the Permian mass extinction was huge. The evolution of fishes and land vertebrates took place during the Paleozoic era, and also land plants came to be. Tectonically, the continents came together and separated twice, and the final supercontinent, Pangaea, formed in the late Paleozoic and was beginning to break up just as this era ended. The Mesozoic era lasted from 248 to 65 million years ago. The supercontinent Pangaea was beginning to break up at the beginning of the Mesozoic. There were mass extinction events twice during the Mesozoic at the end of the Triassic and the Cretaceous. Reptiles dominated in the Mesozoic, and the continents separated to pretty close to today's position by the end at 65 million years ago. So what caused the mass extinction at the end of the Mesozoic era? Well, that was a meteor impact. And we've found the meteor crater at a place called Chicxulub, which is in the Gulf of Mexico, just off of the coast of Mexico. The crater is 110 miles in diameter. This meteor impact would have caused firestorms, a giant tsunami, earthquakes, volcanic eruptions, atmospheric dust in the atmosphere that blackened the sky for years and led to the death of plants, which led, of course, to the death of animals. About 85% of all species went extinct at the end of the Mesozoic, and 100% of land animals over 55 pounds did not survive. But into their space came an explosion of mammals, which began to proliferate in the Cenozoic era. From about 65 million years ago to today is the Cenozoic era. And during this time, some tectonic activity continued to happen. India crashed into Asia and began to make the Himalayas, for example. And mammals really thrived and grew to a vast abundance. Also, grasses came to be, and the land plants, of course, that we see today. Humans came along towards the very end of the game only about 2 million years ago, so you can dismiss all those old B-movie images you have of cavemen and dinosaurs. They didn't even come close to happening. So that's a brief history of time. We're going to look at mass extinctions in particular in a lot more detail.